Module 3. Module 3 is mainly comprises of the first part is transformer, then we have got wiring. Start with the transformer first. The transformer is a electrical machine. The machine means it is converting basically one form of energy into another form of energy. For example, there is a machine. If you are giving input a mechanical energy, then if you are getting a electrical energy out of it, then it is called as generator. Then if there is a machine, if you have got a input as a electrical energy, then if you are getting output as a mechanical energy, then the machine is called as motor. Then what of the transformer? The transformer is a machine. Transformer is the machine which is not converting any energy, but it is transferring electrical energy from one circuit to another circuit. That is a function of the transformer. That is transferring the electrical energy from one circuit to another circuit. That is a function of the transformer. Then what is the importance of the transformer in the electrical system? That we will look into step by step. That is, we are studying a transformer, its construction, principle of operation, EMF equation, then losses and efficiency, and the regulation. These are the things we are studying in the transformer. We will go by this step by step. Then start with the transformer. Here we are pointing out some of the important points here. The transformer is an AC machine. I told you it is an AC machine. Basically, the electrical machines are classified into under two different heads. One is called as the AC machines, then we have got a DC machines. In the AC machines, we have got AC generator, then here we have got, we are calling this as a alternate. It is also you are studying in your unit number 4 and 5, alternator, or it is also called as synchronous generator. Then we have got the AC motors. There are different types of AC motors. AC motors. Here you have got synchronous motor and asynchronous motors. Basically, here it is comprises of the induction motor, three-phase and single phase. And the third category of the machine is what you are calling here is a transformer. Under this, once again, you have got a single phase and a three-phase. Single phase transformer and a three-phase transformer. Then the DC machines, we have got a, once again, two types of machines. One is DC generator and we have got a DC motor. Under DC generator, we have got, broadly it is classified into self-excited and separately excited generator based on its excitation, separately excited. Under self-excited, we have got three types of generators. One is called as series generator, shunt generator, and compound generator. Once again, under compound generator, we have got it is long shunt compound generator and short shunt compound generator. Once again, under this, we have got a cumulative differential and level compounding. If you are taking a specialized electrical engineering, then you are studying. Under DC motor category, here, once again, you have got, broadly it is series, shunt and compound motors. Once again, you have got a long shunt and a short shunt under compound shunt. These are the classification of the electrical machines. Now we are concentrating on first transformer, that too you have got single phase transformer. Also you are studying a self-excited series, shunt and compound generator. You are also studying series, shunt and compound motors. Also you are studying AC alternator and also you are studying the induction motor. That is fundamental principles, then how the construction features and the characteristics and the performance evaluation of these machines and their applications. Now we will concentrate on single phase transformer. Okay, here the some of the important point that I am listing out for a transformers. The basic function of the transformer is it transfers the electrical energy from one circuit to another circuit. It is the basic function is it is transferring the electrical energy from one circuit to another circuit. Does so without change of the frequency. The another important characteristics of the transformer is when if it is transferring the electrical energy from the one particular circuit, from one circuit to other circuit, then the frequency remains the same. If we are applying a 50 Hz supply here, if we are transferring, its frequency is also a 50 Hz. Means transfer the electrical energy from one circuit to another circuit, does so without a change of frequency. Means with the same frequency it is transferring the electrical energy. The transferring technology, that is the fundamental principle of transferring the electrical energy from one circuit to another circuit, is based on the electromagnetic induction. Electromagnetic induction means the transferring of the electrical energy from one circuit to the another circuit is because of electromagnetic induction. Has electrical circuit that are linked by a common magnetic circuit. I'll tell you what you mean by this. Then its basic construction requires no moving parts, so it is called as static transformer. That is, the basic function of a transformer is to transfer the electrical energy from the one circuit. That is, you can call this is one circuit. Here you are giving a input electrical energy. Then I want to transfer this electrical energy from this circuit to this circuit. That is what I am getting is the electrical energy output from this circuit. Means the electrical energy it is transferring to the second circuit. This transferring takes place because of the electromagnetic induction. Magnetic induction. The one more thing you have to observe here, there is no electrical connection between the one circuit to another circuit. No electrical connection. Then how the power is transferring? The power is transferring from here to here because of electromagnetic induction. Then what you are calling is has electrical circuit that are linked by a common magnetic circuit. Means the linking, the transferring is, these are the magnetically linked. These two circuits are magnetically linked, however electrically separated. That is what we are calling is transferring the electrical energy from one circuit to another circuit by electromagnetic induction. However, there is no electrical connection from one circuit to another circuit. Then if you are observing here, there are two circuits. As such, there is no moving part in this. There is no moving parts. If you are considering the generator or motor, there is one stationary part that is called as stator. The another part is the rotor. Means they are called as rotating machines. However, in the case of the transformer, the first circuit and the second circuit that we are calling, where you are inputting, that circuit is called as primary circuit, where you are getting the energy, transferred energy that you are utilizing, that is you are calling as a secondary. These two windings are stationary. As such, there is no movement. Therefore, this device is called as static device. It is called as static device. Means as such there is no moving parts in this. Therefore, the efficiency of a transformer as always more than 90%, because as such there is no rotational losses in a transformer. Therefore, the efficiency of the transformer is greater than the other types of machines. Means basically the transformer is transferring the electrical energy from one circuit to another circuit by electromagnetic induction. There is no electrical connection between the two circuits. That is the function of the transformer. Okay. Then some more points we have to discuss here. That is, a transformer is a device that makes use of the magnetically coupled coils to transfer the energy. The operation is very simple. I have got one winding here. I am inputting electrical energy. Means you are applying a AC voltage here. Then what happens? There is a alternating current is flowing here. Then whenever there is a current is flowing through the winding, then it is producing its own magnetic field. Its own magnetic field. Then I have got another winding nearby to the same winding. Then whatever there is a flux produced by the first coil, which is linking with the second coil. See here, this is linked by the second coil. What is the current here? Alternating current. Because of application of VAC, there is a IAC is flowing. Because of the current is flowing, then alternating flux is producing. What is the nature of the flux? It is also alternating in the nature. This alternating flux is linking with second coil. Then, according to electromagnetic induction, here the coil is stationary, the flux is continuously changing here. Because of changing flux, there is an induced voltage. Means there is a voltage is producing here. If the voltage is available, if you are connecting any load here, it is capable of delivering the current here. That is what is linked. Transformer is a device that makes use of the magnetically coupled coils to transfer the energy. Means we need two magnetically coupled coils. Means they are mounted on common magnetic core. That will come back when we are explaining in detail the construction. It is typically consists of one primary winding coil and one more secondary coil. That is where we are inputting here electrical energy. This coil is called as the primary winding. It is called as the primary winding. Called the primary side of the transformer. The secondary winding and its circuit is called the secondary side of the transformer. Where you are trapping the electrical energy, means where there is a inducing the voltage from because of the first. This is what we are calling as secondary winding, where we are connecting the load, secondary side. If one of those winding, the primary is connected to an alternating voltage source, an alternating flux will be produced, alternating current will flow, alternating flux is producing. This mutual flux, that is a flux produced by the first coil which is linking with the second coil, this is called as mutual flux. It is called as mutual flux. Mutual flux will be produced. The mutual flux will link the other winding, the secondary, and will induce the voltage in this. That is this E2. Therefore, there is a transfer of the electrical energy from the primary winding to the secondary winding because of electromagnetic induction. Okay. Then the importance of the transformer in a power transmission system, usually the voltage is generated, the maximum voltage is generated around 30 kilovolts, and in the power plant we have got a step up voltage. Means we are stepping up the voltage here from 30 kilovolts to nearly 500 kilovolts here. Then for 500 kilovolts you are transferring the energy. Then where you need the voltage, once again what you are gradually are stepping out in the distribution level or sub-transmission level. The objective of the transformer is to increase the voltage level so that we can reduce the current. If we are reducing the current, the conductor size will reduce. If the conductor size will reduce, then the resistance of the circuit reduce, and if the circuit resistance is reducing, then I square R loss is also reducing and the efficiency of system will increase. That is the one advantage. The second advantage is if the current is reducing, then the conductor size is reducing, then the cost of the conductor is also reducing, and supporting structure for a smaller conductor is also reducing. Hence, there is a total economy of you are getting out of high voltage transformer rather than the low voltage transformer. Therefore, for transmission you are stepping up voltage. For secondary transmission you are reducing to 44 kilovolts. For distribution purposes we are going for 4.6 kilovolts. Ultimately you are using the 440 volts 3 phase or 240 the single phase. That we are seeing here, how we are getting here. That is your power plant here. Then the transmission grid here, you are stepping up the voltage here. Then you are stepping down here for what you are calling it, this is a secondary transmission. For a larger load, directly you are tapping to the industries. Then once again you are stepping down the voltage here and you are using for commercial purposes. Once again in the distribution system, we are giving the residential areas. This is how you are transmitting the electrical energy from generating station to the distribution system, where you are using at the different stages. There is a transformer here, transformer here, transformer here for the economy purpose. That is, you are stepping up the voltage so that the conductor size will reduce, the efficiency will increase. You are saving the lot of the money on the transmission system so that it is a less burden on the consumer. Okay. For distribution purposes, once again the high voltage you are reducing to the low voltage, and required voltage you are get it from the once again the transformer. Here for stepping up here using the transformer in the plant side, whereas in the distribution side you are stepping down the voltages. In the next class we will see the principle of operation, the construction of the transformer.